Welcome back, everybody, for another deep dive. Today, we're going to be looking at a paper that's had a really big impact on machine learning.
Yeah, absolutely.
Attention is all you need. And, just from that title,
Catchy.
yeah, catchy, right? You kind of get a sense that this is going to be something,
Changing the game a little bit.
yeah, maybe a little revolutionary. And in fact, it kind of was. It introduced this idea of the transformer model, which has really been incredibly influential, especially in natural language processing. So, helping computers understand and work with human language.
Yeah, it's had a huge impact.
Yeah.
I think it's really fair to say it was a paradigm shift in how we think about processing sequential information.
Okay, so let's break that down a little bit. What were we doing before? What were the problems? And then how did this paper come along and kind of shake things up?
So traditionally, we had these models called recurrent neural networks, RNNs,
Okay.
and they process information step by step, kind of like reading a sentence word by word.
Okay, so very linear.
Yeah, very linear. And that works okay for short sequences. But when you start dealing with really long sequences, like a whole paragraph or even a whole document, these models start to struggle.
I can imagine kind of like losing the thread.
Exactly. They have trouble remembering information from earlier in the sequence.
Mm.
And it also makes them really slow to train because you have to process everything one step at a time.
Right, and we're always looking for more speed.
Absolutely. So there were some attempts to get around this with things like convolutional neural networks.
Like trying to look at bigger chunks.
Right, trying to process things in parallel.
Yeah.
But they still had limitations in terms of capturing really long-range dependencies.
So enter the transformer.
Exactly. The transformer comes along and says, you know what? Forget about this whole step-by-step processing thing. Let's just look at everything at once.
Okay, bold move.
It was. And it's all based on this idea of attention.
Attention. Okay, so now I'm really curious. What do we mean by attention in this context?
So think about how you read a sentence. You don't just focus on each word individually.
Right. No, you're kind of jumping back and forth.
Exactly. You're paying attention to different parts of the sentence at the same time to understand the overall meaning. And that's what attention mechanisms allow these models to do. They can focus on the most relevant parts of the input, regardless of their position in the sequence.
So it's like giving the model the ability to kind of prioritize its focus.
Exactly. And this is what makes the transformer so powerful, because it can capture these long-range dependencies that those older models struggled with.
I see. So instead of being limited by this linear step-by-step process, it can sort of see the whole picture at once.
Exactly. It's like looking at a jigsaw puzzle and being able to see all the pieces at the same time instead of having to put it together one piece at a time.
Okay, that's a great analogy.
Yeah.
So how does this attention thing actually work? What's going on under the hood?
Well, at the heart of it is something called scaled dot product attention. And it's basically a way of measuring how much each word in the sentence should be paying attention to every other word.
Okay, so it's giving each word a score based on its relevance.
Exactly. And it does this using some clever math that I won't bore you with. But the key thing is that it's very efficient to compute, which is important when you're dealing with these massive models.
Right, we want to keep things moving.
Absolutely.
Hmm.
But it gets even cooler because the transformer doesn't just use one attention mechanism. It uses multiple attention mechanisms in parallel. And this is called multi-head attention.
Multi-head attention. So it's like having a team of experts each focusing on a different aspect of the sentence?
Exactly. One attention head might focus on the relationships between verbs and nouns. Another might focus on the overall sentiment of the sentence, and so on.
Wow, so it's really getting a very nuanced understanding of the language.
Exactly. And this is one of the things that allows the transformer to perform so well on a variety of tasks.
This is all incredibly fascinating, but I have one question that's been bugging me. If the transformer is looking at everything at once, how does it keep track of the order of the words in a sentence? It seems like that would be pretty important for understanding meaning.
You're absolutely right. Word order is crucial. And that's where positional encoding comes in.
Positional encoding.
Yeah, basically, it's a way of adding information about the position of each word to the input. So even though the model is processing everything in parallel, it still knows which word came first, which word came second, and so on.
So it's like giving each word a little tag that says, hey, I'm word number 3.
Exactly. And they do this using some special functions called sine and cosine functions, which might sound complicated.
They do.
But the main point is that it gives the model a way to understand word order even without processing things sequentially.
I see. So it's having its cake and eating it too. It can process everything in parallel, but it still doesn't lose that crucial information about word order.
Precisely. And that's what makes the transformer so powerful.
Okay, so we were talked about attention, we've talked about positional encoding. What else makes this self-attention thing such a big deal?
Well, there are three main advantages. First, it's computationally more efficient than those older models,
Yeah,
especially for long sequences.
we like efficiency.
Absolutely.
Yeah.
Second, it's highly parallelizable, which means we can train these models much faster using modern hardware.
Even better.
And third, it allows the model to learn long-range dependencies much more easily because it doesn't have to go through all those intermediate steps.
Okay, so it's faster, more efficient, and better at understanding relationships between words.
Exactly. And that's why the transformer's been so successful.
Okay, so we've laid the groundwork. We've got a sense of what the transformer is and why it's so revolutionary. Let's dive into some of the specifics of how this all works in practice.
Let's do it. So how does all of this attention and positional encoding actually translate into results?
Right, because at the end of the day, it's got to do something useful.
Absolutely. So one of the big breakthroughs with the transformer was in machine translation.
Oh, yeah, that's a classic problem in natural language processing.
It is. And before, the transformer machine translation systems were pretty clunky, let's be honest.
Yeah, you'd get some pretty funny results sometimes.
Exactly. But with the transformer, we saw a huge jump in the quality of translations. Suddenly, you could translate long, complex sentences and get results that were much more accurate and natural sounding.
So no more of those hilariously bad translations?
Hopefully not, but it goes beyond just getting the words right. The transformer was able to capture the nuances of language, the idioms, the humor things that were really difficult for machines to grasp before.
Wow, so it's not just about literal translation, it's about understanding the meaning behind the words.
Exactly. It's about context.
Yeah.
And that's where the transformer really shines.
Okay, so translation is one area where the transformer has made a big impact. What about other applications?
Well, one of the beauties of the transformer is that it's incredibly versatile. It can be applied to all sorts of natural language processing tasks.
So it's not just a one-trick pony.
Not at all.
Yeah.
For example, it's been used very successfully in text summarization.
Okay, so taking a long document and condensing it down to the key points.
Exactly. And it can do this really well because it can understand the relationships between sentences and paragraphs and identify the most important information.
I see. So it's like having a super efficient research assistant.
That's a great way to put it. And it's also been used in things like question answering.
So like a much more advanced version of Siri or Alexa.
Exactly. You can ask the model a question about a piece of text, and it can give you a really accurate and comprehensive answer.
Wow, that's impressive. So it's like the transformer has unlocked a whole new level of understanding for machines.
It really has. And it's opened up all sorts of possibilities for how we can use AI to interact with language.
Okay, so we've talked about the successes, but were there any challenges that the researchers faced in developing the transformer?
Oh, sure. Of course. One of the big ones was actually training these models. Because they're so large and complex, they require a lot of data and a lot of computing power.
So it's not something you can just do on your laptop.
Not really. But luckily, we've seen huge advances in computing power and data availability in recent years. So that's made it possible to train these massive models.
Okay, so the stars kind of aligned in a way.
They did. And another challenge was actually figuring out how to optimize these models. Because there's so many different parameters and settings, it can be really tricky to find the best configuration.
So it's like fine-tuning a race car. You've got this powerful engine, but you need to get all the other parts working together perfectly.
That's a great analogy.
Yeah.
And the researchers had to experiment with different architectures, different hyperparameters, different training techniques to really get the most out of the transformer.
So it was a lot of trial and error.
There was. But the results speak for themselves.
They certainly do. So I think we've covered a lot of ground here. We've talked about the basics of the transformer, how it works, why it's so powerful, and some of the challenges involved in developing it.
Yeah, we've given a pretty good overview, I think.
I think so too. But I'd love to shift gears a little bit and talk about the bigger picture. What are the societal implications of this kind of technology?
That's a really important question and one that we should all be thinking about. Because the transformer and other AI models like it are going to have a huge impact on our world.
Okay, so where do we even begin? What are some of the areas where we're already seeing the effects?
Well, one obvious area is in the way we communicate. The transformer has made it easier than ever to translate languages, to access information from around the world, to connect with people who speak different languages.
So it's breaking down barriers in a way.
It is. And that has the potential to foster greater understanding and collaboration between cultures.
That sounds very positive, but I imagine there are also potential downsides we need to be aware of.
Absolutely. One concern is that these models can perpetuate and even amplify existing biases in the data they're trained on.
Right, because they're learning from us and we're not always perfect.
Exactly. So it's crucial that we develop these models in a responsible way and that we're aware of the potential for bias.
And what about the impact on jobs? Is AI going to take over all our jobs?
That's a question that comes up a lot. And it's understandable that people are concerned. But I think it's important to remember that AI is a tool. And like any tool, it can be used for good or for bad.
So it's up to us to use it wisely.
Exactly. We need to think carefully about how we develop and deploy these models and ensure that they're used in a way that benefits society as a whole.
I think that's a great point to keep in mind as we continue to explore the potential of AI. But let's bring it back to the paper for a moment. What were some of the key takeaways or insights that the researchers highlighted in their work?
Well, one thing they emphasized was the importance of simplicity.
Simplicity.
Yeah,
But this all seems pretty complex to me.
it is. But at its core, the transformer is based on a relatively simple idea, using attention mechanisms to process information in parallel. And that simplicity is part of what makes it so elegant and powerful.
So it's not about throwing more and more complexity at a problem, but about finding an elegant solution that works.
Exactly. And they also highlighted the importance of thinking differently. The researchers behind the transformer weren't afraid to challenge the status quo, to question the assumptions that everyone else was making.
So it's a reminder that sometimes you need to step outside the box to make real progress.
Absolutely. And they were also very generous in sharing their work. They made their code and their findings publicly available, which allowed others to build on their work and accelerate progress in the field.
That's a great example of the power of open science and collaboration.
It is.
Oh,
And it's something that we should all strive for.
I agree. So looking ahead, what's next for the transformer and for attention-based models in general? Where are the frontiers that still need to be explored?
Well, one area that's particularly exciting is in the development of even larger and more powerful models.
So we aren't done yet.
Not even close.
Yeah.
We're seeing the emergence of models with billions or even trillions of parameters. And these models are capable of performing even more complex tasks with even greater accuracy.
Wow. It's mind-boggling to think about what might be possible.
It is. And another area of active research is in making these models more efficient. Because as they get larger, they also become more computationally expensive to train and deploy.
So it's a trade-off.
It is. And researchers are working on new techniques to reduce the computational cost of these models without sacrificing performance.
That sounds like a tough challenge.
It is,
Yeah.
but it's an important one because we want to make these powerful models accessible to everyone, not just to those with massive computing resources.
I think that's a really important point. And it brings us back to the societal implications that we were talking about earlier. It's not just about developing the technology. It's about ensuring that it's used in a way that benefits everyone.
Absolutely. That's the ultimate goal. And it's not just about making them more efficient. We also need to make them more interpretable.
Okay, so being able to understand how they're making decisions.
Exactly. Because right now, these models are kind of like black boxes. We put data in, we get results out,
Right.
but we don't always know what's happening in between.
Right, so it's hard to trust something if you don't understand how it works.
It is. And that's a big challenge for researchers right now, figuring out how to open up these black boxes and make these models more transparent.
So it's not enough for them to just be powerful, they also need to be accountable.
Exactly. And that's something we need to keep in mind as we continue to develop and deploy these models.
I agree. So we've talked about the technical challenges, but what about the broader societal implications? What are some of the big questions that we need to be asking ourselves as AI becomes more and more powerful?
Well, one of the big ones is about the nature of intelligence itself.
Hmm.
What does it actually mean for a machine to be intelligent?
That's a deep question.
It is. And it's one that philosophers have been grappling with for centuries. But it's becoming increasingly relevant as AI systems become more sophisticated.
Right, because if a machine can perform tasks that we once thought were uniquely human, what does that say about us?
Exactly. It challenges our understanding of what it means to be human.
And another question that's often raised is about the impact of AI on jobs.
Yeah, are robots going to take over all our jobs? It's a valid concern. And it's true that some jobs will inevitably be automated.
But I think it's also important to remember that new jobs will be created as well, just like they always have been throughout history.
Exactly. And I think the key is to focus on developing skills that are uniquely human skills, like
Mm.
creativity, critical thinking, and emotional intelligence.
So it's not about competing with machines, it's about finding ways to collaborate with them.
Exactly. And using AI to augment our own abilities.
I think that's a really hopeful message, and it speaks to the importance of education and lifelong learning.
Absolutely. We need to prepare ourselves and future generations for a world where AI is increasingly prevalent.
So we've covered a lot of ground today. We've talked about the technical details of the transformer, we've talked about its impact on various fields, and we've even touched on some of the philosophical and societal implications of AI.
Yeah, it's been a pretty comprehensive deep dive.
I think so too. But before we wrap up, I'd love to hear your thoughts on what the future holds for AI. Where do you see this technology going in the next 5, 10, 20 years?
That's a tough question.
Ah,
But I think it's safe to say that AI is going to continue to advance at an incredible pace. We're going to see even more powerful models capable of performing even more complex tasks.
so things are only going to get more interesting.
They are. And I think we're going to see AI being used in more and more areas of our lives, from healthcare to education to transportation to entertainment.
So it's really going to touch every aspect of society.
It is. And I think it has the potential to make our lives better in countless ways.
Okay, but with that power comes responsibility.
Absolutely.
Hmm.
We need to be mindful of the potential risks and challenges of AI,
Yeah.
and we need to work together to ensure that it's developed and used in a way that benefits all of humanity.
I think that's a perfect note to end on. So, to our listeners out there, thank you for joining us on this deep dive into the world of attention is all you need. And remember, the future of AI is up to all of us. So, stay informed, stay engaged, and keep asking questions.
That's great advice.
I think so too.
Okay.
Until next time.